Hello, this is Josiah Winslow recording for his Programming in Java course at MATC for instructor Mark Cribb. This was my assignment 4, and I'm going to make it quick because I have a lot to say. So, right here, the actual structure of the testing suite that I use hasn't changed since last time. For assignment 3, I also use something like this, except now we're using Chapter 5 and Chapter 6, which have their own challenges loaded, and I've made minor changes to the input choice int and input choice char functions that I use to help myself. Nothing that changes the actual functionality though. So on to the actual challenges. We have stock profit. We need to write a method that calculates this given all the variables. And so we have it down here. Public static double get profit with these arguments. And I divide into a sale factor and purchase factor and then subtract those to get the calculation. And here we have a standard entered number of shares, get the next integer, enter purchase price per share, get the next double, and so on and so forth. We call the get profit function, and then depending on what the profit is, we output a different message. If it's 0, we have no profit or loss. Otherwise, we output the amount and whether it was a profit or loss. And right here, here's a fancy ternary operation again. If profit is greater than 0, then profit, otherwise loss. So let's go ahead and run that. Let's say we have 50 shares. We have a purchase price of $20, commission price of $26. Sale price, 50. I have no idea whether or not these numbers are realistic, by the way. But in any case, that gives us a $1,449 profit. So that's good. And that means that this challenge works, and we can move on to the next one. So, challenge 16 of Chapter 5, present value. We're given another formula for the present value of money sitting in some bank account that we want to get to a future value, given the interest rate and number of years. We have to write a function for that, and here it is. A thing to note is you have to use math.pow and not the caret operator, because the caret operator is a binary XOR. It doesn't do exponentiation like you learned in school. So here we have standard enter future value, in.next double, and so on and so forth. Present value, and we output the result of this function. So let's check that. The original prompt asked for the present value of, for a future value of $10,000. It didn't give us an interest rate, so let's say 2%. Over 10 years. And so the present value that needs to happen for this result is $8,203.48. So that checks out. Challenge 17 of Chapter 5 is rock, paper, scissors. Now, I have the most to say about this, so I'm actually going to save this for last. Chapter 6, Challenge 1. Employee class. We have to write an employee class with certain specifications and use certain information about certain employees to instantiate instances of the employee class and output them to the screen. So here I have an array list with each employee, and I demonstrate all the constructors here. The all-args constructor, the some-args constructor, and I set the rest with some setters. And the no-args constructor, where I have to set everything with setters. And then I add them each to the employees or array list up here. So let's take a quick look at the employee class. Oh, and at the end I output all of them with this funky for loop syntax that loops through. Whoa, I didn't want that. There we go. So it loops through every employee in employees and gives the variable name e to them. So I can do e.getName, e.getID number to output all their information. So let's take a quick look at the employee class. It's very simple again. We have a private string for name, private int for ID number, private string for department, and private string for position. Here we have all the different constructors, which actually all basically use this one, where I take all of these and set them with the setters. And this one, the SumArgs constructor and NoArgs constructor, I use this as a function name, which I think is pretty slick, and I didn't know worked until I literally just tried it. But here we populate the AllArgs constructor with only some of them for these other constructors. And here we have some standard setters and getters. And so that is challenge 6-1. So let's go ahead and test that out. And here we go. These are all correct. And now let's do Chapter 6, Challenge 6. Test scores class. We did something like this in an earlier assignment, but now we have to use a class to do it, where we take 3 test scores, average them out, and then show them to the user. Now, let's actually first take a look at the test scores class, because Mr. Crib, if you remember, during class, I was talking about how I want this constructor right here to be able to take a variable number of arguments, and this is how we do it. Double ... scores. So if you have some like list of parameters up here in a function or in a constructor, the ... if you have that after the last one in like this parameter list up here, then it treats the rest of the arguments you give it, no matter how many, as an array of this data type, and then you can use this name as if it were an array of all of those arguments that you just put in. So I have a field this.scores for a list of doubles that are my scores, and for each of the scores in this list, I add them to the list. And here I have a get score and get scores and add score and remove score at that I used for testing mainly. And here is the star of the show, get average. I have an accumulator for the sum, add each double in scores, and return sum divided by the double that is the score size. I have to cast it to a double, actually, because that is what is needed for the division in order to work with doubles instead of working with integer division. So let's go ahead and... oh yeah, and this is very standard. Again, I have on num scores final int up here, which is equal to 3, and then I loop through that many times to enter that score, and then add that to the test scores object that I instantiate up here. I tested it out though, and the inputting multiple arguments in the constructor works for like 0, 1, 2, 3, 4 arguments. It'll do it right, though I thought I would just leave it blank at first and then add each score as I went along for this example. It was fun to test out the variable arguments thing though. And then here we output the average, get average. So I already have an instance running, so I'll figure out how to use this IDE soon enough. Okay, so enter score 1. Let's say it's a 90%. And score number 2, let's say it's like a 68%. And score 3, a little bit better, but not great, 76%. That averages out to 78. That checks out. Chapter 6, Challenge 19, Fishing Game Simulation. It's more involved, but I was able to manage it. So, we use the die class that is given in the book. It's very simple and very effective. And I make a new one in Fish Die, which I thought was an unfortunate name. And then I make an integer for the fish points. And I have a character Keep Fishing, which is what I store the result of asking the user, do you feel like fishing? Yes or no? And while they keep saying yes, because I keep asking them at the end of this loop too, while they keep saying yes, I loop through this loop. And the loop goes, I roll the die. And then I declare a fish type string and new points int, and I do a switch statement on the value of the fish die, in case it's 1, 2, 3, 4, 5, 6, and default, which I never get to, but I decided to add just in case. For each of those cases, there's a different fish type and new points associated with it, and these all set the right values, and then it prints you caught that fish, adds the new points to your fish score, and asks if you want to keep fishing. And once you don't want to keep fishing anymore, once you're done fishing, it outputs the number of fish points you got, and if that number is greater than 200, which this is one of the requirements too, is printing a different message depending on how many fish points you got. If your fish points is greater than or equal to 200, then it says you're either very experienced or very persistent. Good job. Otherwise it prints, you need practice, better luck next time. So let's play that game for a little while, though not too long because I want to get to rock, paper, scissors. Alright, do you feel like fishing? Yeah, for a little while. You caught a little fish. Oh, that's amazing. I wonder if I can catch another fish. You caught a goldfish. Better. You caught a whale. Whoa! That is extremely big. I caught another whale. Amazing. A huge fish. I caught a snail. Not as impressive, but that's still great. And I keep catching different fish types, and every time it's random. At some point we should see an old shoe. Yeah. And I like the old shoe from the challenge prompt, which gives us no points because it's not a fish. And after all of that fishing, I now have 895 points. So you are either very experienced or very persistent. Good job. So that's that challenge. And finally, let's talk about rock, paper, scissors. Chapter 5, Challenge 17. Now, I had made a video about my algorithm for this that I used to determine the winner. And this works for any rock, paper, scissors like game as long as it is balanced. That is to say, you win against half of the other hand gestures and you lose against half of the other hand gestures if you pick any gesture in the game. And of course, picking the same gesture results in a tie. And you can view that video where I describe my algorithm in great detail up in the top right corner, or in the description if you don't see the card. So I have a linked hash map right here that stores all the different games. I wanted it to be a linked hash map because, well, it's a hash map because I wanted a string key to be associated with a string array value, the name of the game, and the number of gestures in the game, all in order. And I wanted it to be linked because I want to iterate through these games in a consistent order when I ask for the game, what game you want to play. I have an enumerated type called GameOutcome, which can be one of these three different values, and I use that to store the game outcome because I thought it'd be convenient. And here, I'm going to explain most of this at a high level, though I did do quite a bit of polishing to make this game look good, even though it's a console-based game. So I ask for which game you want, which the ask for game function, it loops through all the games that are available to play in g.keyset. We need to do that to get all the keys, and this is why I want it to be linked, because then it'll iterate through the key set in a consistent order, in creation order. And then I asked to enter a game. This should look very familiar to anybody who has had to do something like this in Java, where you have to ask continuously for a number in a certain boundary. And then I get that game from the linked hash map. So that was ask for game. And then we print out the rules for this game. Now the print rules function, because of the way that I structured each of the lists of gestures, if you count up by 2 from any gesture, then all of the ones that you'll hit, and also you go back to the beginning of the array if you go past the end. But if you count up by 2s in that way, in that loopy way, then every item you'll hit, that gesture that you start out with will win against that gesture. So here I loop through all of the gestures, and then for each of them, I count up by 2s in the list of gestures, and then I combine them into a list I call beats. And in the end, I join them with a comma. And also, if there's 2 at the end, then I join them with an and instead. And then I print this gesture beats this gesture, this gesture, this gesture, and this gesture, depending on what gestures I did. So that was, we asked for the game, we got the rules printed out, and now we have the gestures collected in a string array called gestures. The CPU makes a choice, the human makes a choice, which I'm not going to explain this function because it works basically the same as the ask for game function, except it also prints out the gestures with a special function that I'm going to explain later. And then it displays, you chose that, the computer chose that, and then it indexes into gestures with human choice and CPU choice. It figures out who the winner is with my special algorithm, and then I do a switch statement on who won. If it's a tie, it's a tie. P1 wins, then you win. P2 wins, then you lose. And we should never get here, but I added it just in case. And then it asks if you want to play again. And if you say yes, then it'll keep looping. And so I'm going to explain my print gestures with indices function, which the function that asks for which gesture you want to choose uses this to print out each gesture alongside every digit or every number. Like, it'll say 1 is rock, 2 is paper, 3 is scissors, 4 is Spock, 5 is lizard, and so on and so forth for all the gestures. And this is in a special function because I have it formatted in a neat way. So I calculate the maximum length that that string could be with the number and the gesture. And then for each gesture in my list, I have this many in every row, which this is 7 I declared at the top. There we are. Gestures row len is 7. And for every gesture, I output the formatted string, pad it to the left, and it's max len long, which is max len is the number we calculated earlier. And I use a neat little string format hack to do it. So percent minus whatever number S is the format code for padding with padding right with spaces up to the length given. The minus means padding to the right, and the S means string. And then it outputs each gesture like that. And here we've got tab as well to do a little more spacing. And so, oh, hang on, I don't want to run it yet. I actually have one more thing to sort of talk about. I'm not going to talk about the algorithm for this getWinner function because I already did in a video, but I will discuss the problems with getting the difference value that it needs. Because in principle, you could just do P2 minus P1 mod gestures length and it should work. But this algorithm only works if the index is not negative. So if this number right here is negative, or sorry, if the whole difference is negative, then it won't really work. And P2 minus P1 mod gestures length, by itself, Java treats that, it returns a negative number there because, well, if this number is negative, then it returns a negative number. Because, according to the specifications, this statement right here has to be equal to A. And this implies that because this value is greater than 0 right here, then if this value is going to be less than 0, then the whole thing would be less than 0 if I didn't add this plus gestures.length. I said this to somebody on the discussion board who posted a thread about if you're having problems with the negative numbers of the mod, then you can do something else. And then I point out, well, this is what I did, and yeah. So I like, by the way, that whoever posted in the discussion board posted in the discussion board. That's really what I want to see more of from this class, because it's great when people help people. But the function that they mentioned that would also work in this situation, I want to explain here, because there are a few different ways you could have done this. This is the one I ended up choosing. And in this case, we also could have just taken this subtraction, int diff equals P2 minus P1, and then if that's negative, then we could bring that within the proper range just by adding gestures.length without performing the mod. And also, here's the one that the person in the discussion board posted about, math.floormod, which takes on the sign of whatever the second argument is, as opposed to the other one, the percent operator, which doesn't. It uses a different system. And because gestures.length is positive, that means that if we did this instead, the whole result would be positive, and it would just work. So thank you, whoever pointed me towards that, for saying that on the discussion board. And I also looked up that part of the specifications for the math module in Java, and it has advice on how to ensure, no matter what the signs of the first and second argument of mod are, that they're always positive. The result is always positive. And this is the formula that they use for that. And of course, floor mod and abs are math module functions. So in general, we could do this if we didn't know the signs of either side and we still wanted a positive result. However, in practice, we know that gestures.length is positive, so we don't need to do that. But this is a good formula to have in the back of your mind. Alright, now the moment of truth. Let's play a few games of rock, paper, scissors. And let's start out with the classic game. So rock beats scissors, paper beats rock, scissors beats paper. And this is what I was talking about the formatting. And you'll see how nice this is once we start playing the more complicated games. So let's choose rock. The computer chose paper, so I lose. Darn. Let's choose paper this time. Tie game. Let's choose scissors. I win! Yay! And let's play rock, paper, scissors, lizard, Spock, because this is the entire reason that I sort of went crazy with figuring out an algorithm, because I wanted this to be not only simple, but also extensible to pretty much any rock, paper, scissors game that I wanted. So that's game 2 on this list, and it prints out the rules: rock beats scissors and lizard, paper beats Spock and rock, and so on and so forth. And it's got this in a nice formatted list. Let's choose Spock. Lizard beats Spock. And let's choose lizard this time. Rock beats lizard. And we can play this just like the other games. And now let's showcase a different game, which I had talked about in my video, though here I'm going to actually play a little bit of it. So let's play the 15 game. That's number 6. So there are a whole lot of rules to remember for this game. So be lucky that I printed them out for you. I know I'm lucky. I wouldn't be able to remember that list. And here we have all the gestures. Let's try human. The computer chose human. That's a tie. Alright. Let's choose human again. It chose human again. Now the computer chose gun. That means I lose. Human doesn't ever beat gun. And let's try one more time with fire. Tie. Wow. What are the odds? I'll tell you what. 1 in 15. Alright, and fire beats wolf, so I win. And finally, let's play the 101 game. That is a really big number of rules. Do you think you could remember these? Yeah, this is a really awkward game to play in real life, but there are hand symbols for each of these things. Rock, paper, death, cloud, wall, airplane. The website that I got this from has hand gestures for each one of them. And they get pretty complicated. So let's choose number 27, which is computer. The computer chose prayer, and prayer beats computer, so I lose. Let's go ahead and choose TV. That's number 32. The computer chose law. I win. Alright, and let's play one more game. And let's choose video game this time. The computer chose fire. Video game beats fire. Now you're playing with power. Alright. So, with that said, that is my entire assignment 4. But I'm not done yet. I actually want to take a second to talk about my final project. I've already started on it, and I have some details that I want to share. So I've already gotten started on my final project in Java, and there are 5 requirements for the final project. It has to use file reading or writing, it has to use at least one class, has to have at least one method, has to use arrays and or array lists, and it has to use recursion. Now, this can be satisfied by writing an entire programming language and writing the interpreter in Java. Now, that sounds pretty ambitious, but I've been managing so far. And the idea of the programming language I have in mind that I'm going to create is, usually in most programming languages, programs execute line by line, mostly in order. But what if it didn't? What if the interpreter for a programming language just executed lines in whatever order it wanted, whenever it wanted? That's the idea of my programming language. Now that sounds pretty hard to work with, and it is. Let's just get to the interpreter, shall we? So here I have a prototype of an interpreter for my programming language written in Python. Now, I'm not going to show you all of it, mainly because 1, it's not really finished, and 2, the code is really messy. But I am going to show you a few programs working in it. So, right up there you can see print hello world. Now, that should sound familiar to you, and that's because this prints hello world in my programming language. Now, all lines start with a line number right here. It really doesn't matter what this line number is. It doesn't have to be in order, and in fact, the interpreter sometimes will disregard the order. Not sometimes, all the time. It'll disregard the order. So, all statements start with a line number, then there's the statement, and we can't forget the ending semicolon. So let's run that program in my interpreter. Hello world.text, and it outputs hello world. That's amazing, isn't it? Now, you could split this off into 2 lines if you wanted to, where one of the lines printed hello and the other line printed world. But there's a problem with this. The problem is, because the interpreter executes statements in whatever order it wants, it might do hello world, but it might do world hello instead. Invalid syntax. Oh, I keep forgetting to add the semicolon. It's extremely important. But let's run this program. Now remember, sometimes we might get hello world, but other times we might get world hello. Because again, it executes in whatever order it wants. Now you might be thinking to yourself, how can I get this to execute in the order that I want? Well, that's where some other statements in my language come in. I can write a defer statement on a line, which, as long as this condition in here is true, then this line will not run. If the interpreter chooses it, it just skips this one if this condition is true. And what this condition 1 is saying is, if line 1 is on the to-do list, then this is true, and we should defer this line until number 1 is off the list. And how does it get off the list? Simple. If the interpreter chooses it, and it deletes itself from the list because it's done. And then once this is deleted from the list, then this statement will no longer be true. And so it has an option to execute, and since it's the only line, it will execute. So we can go ahead and run that. And finally, we get a consistent hello world. And I have one more program that I want to show off. I'm not going to explain it all, mostly because it is kind of complicated. It uses some more complex features of my language. It even includes expressions, which I have to parse recursively in order to evaluate. It includes compound statements, separated by commas. It even includes the word forget. And what's this? What is any of this? I'll explain as soon as I finish up with this final project enough to showcase the rest of the way. But just know that this program, it's called 99 Bottles, and what it does is it prints the lyrics to 99 bottles of beer on the wall. It's a classic song that sometimes people use as a programming challenge. 99 bottles of beer on the wall, 99 bottles of beer. Take one down, pass it around. 98 bottles of beer on the wall. 98 bottles of beer on the... And it keeps going and going until you get to no more bottles of beer on the wall. And then it goes, no more bottles of beer on the wall, no more bottles of beer. Go to the store and buy some more, 99 bottles of beer on the wall. And so that's what my program does. And if you notice, it says 3 bottles, 2 bottles, 1 bottle. No more bottles. It took some doing to get that part to work. But rest assured, this works. Which is amazing because I wrote this parser in a few days. And I'm going to port it over to Java once this becomes my final project. So, with that said, I hope you like this assignment, Mr. Crib. Once I'm finished with it, I really hope you'll use it, find great use in the programming language, because it's been pretty interesting to make so far. And I also hope you give me a good grade on the assignment 4 that I made this video to actually showcase. Wow, we lost topic quickly. Take care.